This video is a short video on the equilibrium constant. You will not have to do a lot in your first year on the equilibrium constant, but we've got other videos that go into detailed views of the equilibrium constant. This is the one for Module 3. There'll be further ones in Module 5 that expand upon this, but this is the simple ones that come if you do an AS exam. Now, we're just going to talk about the normal stuff, forward and backward reactions at the same rate in a closed system. It is your definition of equilibrium. Homogeneous is when they're all in the same state. So your reactants products are in the same state. See this all in the same state. So they're basically, this is a homogeneous equilibrium, all gases. Now, in AS, you're only going to talk about homogeneous equilibrium. So here we go. Now, Le Chatelier's principle is the position of the equilibrium of the system changes to minimize the effect. So basically it's an opposite effect. So if something goes up, it will make it go down. If something goes down, it will make it go up. Okay, so higher concentration is imposed, system will lower the concentration. Higher pressure is imposed, system will lower the pressure. If a higher temperature is imposed, the system will lower the temperature. It won't bring it back to its original levels. It will just bring it down lower than when it was hired. Now the opposite happens when the concentration is lowered, or the pressure is lowered, or the temperature is lowered. It will do the opposite and bring it back up. Okay, so it's a kind of opposite thing that happens. But we've already done this in other videos, so I'm going to move on. So here you have the equilibrium constant. Now the equilibrium constant looks like this. So first of all, we're going to look at these. So these numbers in your equation, I like to call them. Okay. But some people call them coefficients and things like that. But basically it's the numbers in a balanced equation. You will raise your concentrations to the power of that. So C and D is your products divided by your reactants. So products divided by your reactants. And we've got concentrations here, which is the square brackets. So as you can see here, I've got my products, reactants, square brackets is a concentration raised to the powers that are in the equation. So if we were doing it with something like this, okay, and we carried on, let's go, there we go. So here you have a homogeneous equilibria, and I'm going to quickly just write out the actual expression. So it would be Kc. We go for the products. The products are NH3, okay, so NH3, okay, square brackets, really important. Okay, so square brackets, let's just do that. There we go. Square brackets really important. We look at the number is 2, so therefore we got 2. Okay, so there we go. Divide that. We've only got one product, so we leave that like that. Then we've got 2 reactants. So there we go. Okay, N2. And there we go. Let's put some square brackets around them like we always do. Okay, okay. And we look at the equation again, nothing by the 2, nothing by the nitrogen, a 3 by the hydrogen. Okay, and there you have your expression. Now when it comes to your examinations, you need to do that all the time. So really, really important. Products divided by reactants, raise it to the powers. And if you're asked to draw an expression, draw it just like this. Okay, really, really, really important. Okay, now we've got our expression. The simplest question they can do in your first year, okay, will just be to put the numbers in. So put the numbers in. So here we've got the numbers, and it's really important you get used to the wording. At equilibrium, the following concentrations were measured, and that's the equilibrium amount. So you just plug the numbers in. So let's move that to the side and highlight them. Okay, and then let's plug the numbers in. So we just plug the numbers in. What I would say is get used to using these in your calculator. Okay, it's really, really easy to get this wrong, okay, and therefore you've got a Kc value of that. Now, when it comes to units, so we'll go through some units with you. Now, units don't really get asked in the first year, but, okay, it's really good to know, and it's not that hard. So what we do is we write out the units. So there we go. Okay, and that units is going to be like that, and it's squared. I've just copied the units, because its concentration is moles per decimeter cubed. Okay, so then we go, right, let's do it again. Okay, and there we go. And that's a 3. All we've done is copy this, put moles per decimeter cubed in. So what we do is they can cancel. So if you look, there's 2 on the top and there's 4 on the bottom. That's where you've got to think about it. 2 on the top, 4 on the bottom. So the 2 on the top cancels. We get rid of one of those. Well, there's 3 left, so we get rid of one of those, and that becomes 2. Okay, so we've cancelled out 2 of our units. Then what we do is to make the units, going from the denominator to the numerator is like timesing by -1. So we have to times it by -1, and we have to times it by the number outside. So basically that means moles is going to be to the 2. Decimeters is going to be to the 6. I deliberately haven't done the minus or the plus or the sign. Okay, so if you're then timesing that by -1, you've times it by 2 first, and now you're timesing it by -1 to get it up the top. That means that becomes -2, and that becomes 6, which means the examiners like you to put it like this. They like you to put the +1 first. Okay, and there you have the unit. Okay, so basically that is how you do units. We'll go through one more question, but that's really all it is for AS when it comes to the equilibrium constant. Like I say, if you want to do more, go to Module 5 and go to 3 videos there on how to do further calculations with equilibrium constants.